Elementary statistics, practice test number 5 covers chapters 10, 11, and 12. Practice test number 5, module 5. Chapter 10, correlation and regression. Chapter 11, goodness of fit and contingency tables. Chapter 12, analysis of variance. And we are going to go with chapter 10, correlation and regression. Here's the first question.
Number 1, given the sample data A correlation, find the value of the linear correlation coefficient R. B correlation, test the claim that there is a linear correlation between the two variables X and Y. Use both A, method 1, and B, method 2. Alpha 0.05. C, regression. Find the regression equation. D, find the best predicted value of Y when X is equal to 2.
So we are looking at correlation, and let's look at a couple of things. The first thing is a scatter plot and strength of the linear correlation. Just to remind you, a scatter plot is a graph of the ordered pairs X and Y. X is the independent variable, Y is the dependent variable, just what we learned in elementary algebra. As we look at this case, what do we notice? Distinct straight line or linear pattern. We say that there is a positive linear correlation between X and Y. As X increases, so does Y. So we can clearly see that. This one, what do we notice? We notice again a distinct straight line. So there is a linear relationship, but this time there is a negative linear correlation between X and Y. The slope is negative. As we look at this case, there is no correlation between X and Y. When there is a linear correlation, a strong positive linear relationship means normally R is fairly large and close to 1, in this case 0.7 or larger. On the negative side, then it's close to -1, that means -0.7 or smaller. And in essence, we can look at the absolute value of that. So correlation is fairly strong when the numbers are on the side, close to -1 or close to 1. In between, it is not. Needless to say, correlation doesn't imply causation and causality. So back to the question. On a normal basis, we do this stuff by technology. However, this is a small piece of data, and I am going to go through the process just so you are exposed to it at least once. As you can see, the formula for R is pretty complicated, and therefore we need to calculate various summations, and that's the first step we're going to take. Number 1, if we put this X in this column, Y in this column, X times Y means 1 times 2 is 2, 1 times 8 is 8, and so on and so forth. X squared, look at the first column, square each data entry. 1 squared is 1, 1 squared is 1, 3 squared is 9, 5 squared is 25. The last column is Y squared, so take a look at the second column and square every number. The result will be the last one. Now we need to add them up, so we add the following row. This is summation of X, summation of Y, summation of XY, summation of X squared, summation of Y squared. Now, if we go to this formula, all we have to do, plug in. N is a 4 because we have 4 pieces of data. Okay, 1, 2, 3, 4. And then summation of XY, you get it from here. Summation of X, summation of Y. So plug in everything and do the math. As you can see, this gets very complicated. as the number of data increase. Therefore, this is not done by hand. How would we do it? You can use any type of a technology. For example, I gave you the TI calculator commands in the last module in Canvas. So you clear the list L1 and L2, and you input X into L1, Y into L2. You run a linear regression test or linear regression t-test, with X sub 1 being the first list, X will be the first list, Y will be the second. And you do the calculation, and it results in the following. It gives us a lot of information. For this part, the one we want is R. So take a look at the value of R, and if you do the rounding, you get what we have. When it comes to rounding, you really don't want to round unless you're asked to, and follow as to how many decimals to be on the safe side. I have other calculator resources for you. I found this one to be pretty helpful, and again, it is posted. If you go to the last module of Canvas, I highly recommend you explore that. All right, let's go through the process. When we do the test of hypothesis, there are always 4 steps: null and alternative hypothesis, test statistic, critical value, and we make a decision. So the null and alternative hypothesis is always rho equal to 0, H0. Rho is not equal to 0, H1 or HA, the alternative hypothesis. And this happened to be the claim because we are checking to see if there's a correlation. Correlation means if we reject H0, there's a correlation. There are 2 different methods to calculate the test statistic. One of them is using the t-test, and take a look at the formula we use here. I want you to take a look at this formula, and I also want you to look at this formula and convince yourself they are the same. And I'm giving you 2 different types of formulas in case you're dealing with different texts. They are both identical. Notice 1 minus r squared is at the bottom here, but over here is at top because it's a complex fraction. So plug in. We already calculated r to be negative 0.135 from the previous page. We are going to put in. Evaluate the t. The answer is negative 0.1927. In the second method, we don't have to do any evaluation. We've already done the evaluation for R. So the test statistic is the value of R. The next one is using the critical value. When we do critical value, remember, we compare 2 numbers. The p-value compares 2 areas. In that case, you, again, have to use the technology to do so. It's very simple. With that being the case, degrees of freedom is n minus 2, alpha is 0.05, and the t becomes plus minus 4, 303. From the t table, I quickly show you on the next page. For the second method, you use the correlation table. Correlation table, n equals 4, alpha equals 0.05. It results in the critical value of plus minus 0.950. You do the drawing. Notice if you look at the t-test, the critical values are here, negative and positive 4.303. Your test statistic is way into the non-rejection region, NRR, non-rejection region. And if you look at the second case, the same thing, the critical values are plus minus 0.950, and the test statistic, which is negative 0.135, is somewhere in between, way into the non-rejection region, giving you the same result, which means do not reject H0. So I want you to stick with part A only because this is what the calculation gives us. So if we go back to the very first step, if we are not rejecting H0, that means we are rejecting H1, we are rejecting the claim becomes false. Therefore, there is no linear correlation between the 2 variables. When we don't reject H0, there is no correlation. Now, As far as the table, if you recall, this is a portion of T table. On the left side, we have degrees of freedom. At the top row, we have area in one or two tails. And so t-test alpha is 0.05. It's a two-tail test, so we are here. And degrees of freedom n minus 2, we are here. We put them together as follows. So we put these two numbers together, and the answer is 4.303. Because we do know it's a two-tail test, it becomes plus minus. As for the Pearson correlation coefficient, we see the value of n is 4, alpha is 0.05. They come together, resulting in 0.950. And again, because it's a two-tail test, we use plus minus. The thing I want to add, in some texts for the correlation, Pearson correlation table, they may use degrees of freedom. If they do, degrees of freedom is n minus 2. So in this case, it would be 2 here, 3 here, 4 here, so on and so forth. So it depends on the text and which one they give. Now, in this case, we want to find the regression equation. Again, this is not something that is done by hand, but we've already done all these calculations, remember, from the first page. Therefore, let's see how we can calculate the equation. And that means we need to know b sub 0, b sub 1, or a and b. This is y hat equals b sub 0 plus b1x, or y hat equals a plus bx. This is the notation used in TI calculate. So first we find the slope b sub 1. I hope you remember y equals mx plus b, but they have it slightly in a different order here. And so b sub 1, you just plug in everything that you need in this formula and you find b sub 1. Let's do that. N is 4, summation of x, y is 48, so on and so forth. Here's b sub 1. Now, what about b sub 0? Take a look at the formula for b sub 0. For b sub 0, we need y bar. We also need x bar before we move on. Y bar is summation of y over n. We already have summation of y, and there's a total of 4. Same thing for x, summation of x bar over n. Let's calculate those. So y bar becomes 5, x bar becomes 2.5. And now when we put it into this formula, b sub 0 is y bar minus b1 x bar, we end up with 5.455, and we write the formula. Negative 0.182x plus 5.455. I'm really putting in the form of mx plus b in essence. Now, I want you to notice this a and b, both values are given to us from this linear regression t-test. And again, you don't have to do it by hand. The other thing I want to add is this last part. There is no significant linear correlation. We showed there was no correlation. And because of that, the best predicted value is always y bar. Otherwise, you plug in the value of x. By the way, if you pay attention to this value, p, it's way larger than alpha of 0.05. So fail to reject H0. That part is also given. Here's the next example. We are going to do the same on a different question given a sample data. We want to find the value of a linear correlation and test the claim that there is a linear correlation at alpha 0.05. Again, I'm going to do it with two methods because I want you to be exposed to both. And assuming that in 2001 there were 850,000 registered boats, because the table lists the number of registered boats in 10,000s. This means that for 2001, we have x equals 85. Given that x is 85, find the best predicted value for y. And Also, using the information from the previous steps, what proportion of the variation in number of vanities deaths can be explained by the variation in the number of registered votes. Let's go through the process. And as you can see, we have more data. And this is what I mean. As we have more data, things get more complicated. We don't do it by hand, we do it by technology. Let's look at the result of technology and make some decision accordingly. So the first question is find R. So we linear regression t-test and we got this information, as you can see. So find R. Look at R. So you write test the claim. Now remember, there are 4 steps and we have the first step, H0. We basically write row is 0, H1 row is not equal to 0, two-tailed test, and that's a claim. I will show you the details of that again on the next page. Then you have the critical test statistic. You calculate it and you go with the critical value or the p-value, you make a decision. That's the concept. What do you notice here? In this case, I want you to pay attention to the fact that we look at the p-value and we make a decision. By the way, right at top of the p-value, that is your test statistic. So the p-value 1.5081766, notice e minus 4, that means times 10 to the power of negative 4. That means this decimal must move to the left by 4 places. Therefore, your p-value becomes 0.000151, which is less than alpha of 0.05, and you reject H0. So what happens when you reject H0? You accept H1, the claim becomes true. There is a significant linear correlation between the 2 variables. Because there is a linear correlation, then we can use the regression line. So we need to know what's the regression equation. So look at A and B. Here's the regression equation. So therefore, in part D, we can use this formula and replace the x with 8. So we plug in. Because we are dealing with a discrete value, an integer, a whole number, we round this accordingly. So when we round it to the nearest whole number, becomes AD1. Proportion of the variation in number of manatee deaths explained by the variation in the number of votes is R squared. Now, this is given. If it were not, all you had to do, just the value of R that you found, square it. So, and you can change that to a percentage. Therefore, 84.92% is the percentage of manatee deaths that is explained by the variation in the number of votes. Let's quickly do what we did in the previous page by going through the steps. The very first step is going to be identical for correlation. The next step, using the test statistic, and again, I'm referring to this equation and this equation. They may look different, but they are the same. By the way, mu sub R refers to rho, and that comes from H0, and it's always 0 for us. Plug in, the result is 6.7352, very close to what we found in the previous page using a TI. And method 2 simply uses the value of R. Critical value, degrees of freedom is n minus 2. There were 10 pieces of data. 10 minus 2 is 8. And critical value is plus minus 2.306 from the T table. This one from the Pearson correlation coefficient table, or just from the correlation table. R is plus minus 0.632. Let's do the drawing. If you look at the t-test and the graph of a t, you see that the test statistic is way into the rejection region. If you look at this number line, the test statistic is 0.922, which is way into the rejection region as well. Therefore, your decision is to reject H0. So let's stick with part A only. What does it mean when we reject H0? Let's go back to the first one. You're rejecting H0. That means you're accepting H1. That means you're accepting the claim, and the claim becomes true. There is a significant linear correlation between the two variables.